So today we're going to talk about calculating powers of binomials, and we're going to use something called Pascal's triangle. And when I do this, I call it binomial expansion. And really what I'm doing here is I've got binomials raised to different powers, and what I'm doing is expanding it into its polynomial, multiplied out. All right? That's why we call it binomial expansion. It's a binomial to a power, and we're expanding it out. And once you learn how to do this, it's really not too tough. So binomial expansion is the sum of terms that you get when you multiply out a power of a binomial. So the way that we're going to do this uses something called Pascal's triangle. And it was a man, and his last name was Pascal. That's where Pascal's triangle comes from. But it's a triangle, and the coolest thing is that he actually figured out that this works. Because now that we know how this works, it's so easy. So here's what I'm going to do, is I'm going to make a Pascal's triangle. All right? And it starts, you can make one along with me. It starts by putting a number 1 here. All right? And this is what we call row 0. All right? Starts with row 0. Now, we're going to, in the next row, put 2 1s, like this. Now, in the next row, which is technically row 2, because this was row 1, we're going to put 1s out here. And in the middle, we're going to take 1 plus 1 gives us 2. All right? In our next row, we're going to put a 1 out here and a 1 out here. 1 plus 2 gives us 3. 2 plus 1 gives us 3. All right? In our next row, put a 1 out here and a 1 out here. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. In the next row, put a 1 out here and a 1 out here. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. And 4 plus 1 gives us 5. All right? Let's go again. Put a 1 out here and a 1 out here. And we're going to fill in all the middle numbers by adding. So 1 plus 5 gives us 6. 5 plus 10 gives us 15. 10 plus 10 is 20. 10 plus 5 is 15. And 5 plus 1 is 6. Let's do one last row. So I'm going to put a 1 out here and a 1 out here. You can keep going like this forever. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 6 plus 1 is 7. So this was row 1, row 2, so we'll put, I'm not going to mark every row, but just to keep track of these. Down 2 more, this is row 4. Down 2 more, this is row 6. So we went 1 more, we went to row 7. All right, here's the cool thing about this. These are the coefficients of the polynomial when we expand these. So if you look at rows, let's look at row 5 right here. 1, 5, 10, 10, 5, 1. Let's go up above to here. A plus b to the 5th is, the coefficients are 1, 5, 10, 10, 5, 1. All right? So there's where the coefficients come from. Where the rest of this comes from is this. Your first term starts out with your first term to this power, to the fifth. Now each term you go to the right, you're going to take away one power of this and add one power of this. So now I have a to the fourth and b to the 1. Take away one of these, add one of these, a to the third, b to the second. Take away one of the a's, add one of the b's, a squared, b to the third. Take away an a, add in a b, is a, b to the fourth. Take away an a, add in a b, and you have b to the fifth. Really easy. Much easier than trying to write this out 5 times and unfoil it all. All right? So what we're going to do is the next one. This is example 1, and this is a plus b to the 6th. So we're going to go to row 6, and we're going to look at our coefficients. And that is 1. Then we've got 6, 15, 20, 15, 6, and 1. And it's not necessary to write the ones. Now we're going to start out, this is a plus b in parentheses again, so this is a to the 6th is where we start. All right? Take away an a, add in a b. So we've got a to the 5th, b. Put a plus. Take away, add a b. Take away an a, add a b. So a to the 4th, b squared. Put in a plus. Take away an a, add a b. So a to the 3rd, b to the 3rd. Put in a plus. Take away an a, add a b. So a squared, b to the 4th. Put in a plus. All right. Take away an a, add a b. So we've got a, b to the 5th. Put a plus. Take away an a, add a b, and we have b to the 6th. And that's how we end that one. So we did that in much less time than it would take to FOIL that all out. All right? Now, this next one is to the 7th power. So we're going to use this row 7. But to save you, because this is a really long one, I'm just asking you find the first 4 terms. Okay? But the thing that's different here, 2 things. One is we have a minus, and the other thing is we've got a number here. So watch what's going to happen, because this is going to be where you're going to need to calculate. Okay? Instead of just an a and a b, we have an x and a negative 2y. So first of all, our coefficients for the first 4 terms, 1, 7, 21, and 35. So 1, 7, 21, and 35. First of all, my first term, I take this to the 7th power, so x to the 7th. And I'm going to add. Now, take away one of the x's. So I've got x to the 6th. Here's what I have. I have a negative 2y. Put it in parentheses. Put it right here. Put in your plus. Take away an x. So x to the 5th. And the negative 2y is now to the 2nd power. I added one of those in. Put a plus. Take away an x. So x to the 4th. And I've got negative 2y, raise that power 1 to the 3rd. This is why I need my calculator. This part is easy. This is x to the 7th. This is where I've got to start multiplying things out. I've got a 7 and a negative 2. That gives me minus 14 x to the 6th y. All right? The next one. Here's what I have. I've got a negative 2 quantity squared, which gives me 4. So 4 times 21 gives me 84. So plus 84 x to the 5th y squared. Now here, I've got negative 2 raised to the 3rd power, which is negative 8. So negative 8 times 35. So this is going to be a minus. And that gives us minus 280. X to the fourth, y to the third. So if you have something other than a and b or x and y here, if you have a number here, this is what you have to do. So it will cause you to need your calculator to multiply all this out, and these numbers can get quite large. All right, let's turn the page and do another one. All right, it says find the first three terms. So just the first three terms of 2x minus y to the sixth power. Now let's look for our coefficients in row 6. Here's row 6. Our first three terms, our coefficients are 1, 6, and 15. All right, so that's what we're going to start with. 1, 6, and 15. Okay, first of all, we've got a 2x raised to the sixth power. All right, put a plus. Now I've got 2x raised to the fifth because I'm going to take 1 away. And I have a negative y because this is a minus sign, so put a negative y here. My next one is going to be 2x to the fourth, so 1 less of those, and a negative y squared, 1 more of those. Now we need to multiply this out. 2 to the sixth is 64. So this is 64 x to the sixth. 2 to the fifth, whoops, let's not even do this. We put a plus here. I've got 2 to the fifth, which is 32, times 6, which is 192, but it's times a negative. So minus 192 x to the fifth y. If we go to our next term, I've got 2 to the fourth power, which is 16. So 16 times 15 is 240. The two negatives, because I have negatives squared, so that's going to be positive. So this will be plus 240 x to the fourth y squared. So what you'll notice whenever you have a negative here is that each term will alternate negative, positive, negative, positive, negative, positive. All right, because in one case you'll have y to an odd power, or the negative to an odd power. In the next case you'll have the negative to an even power, then negative to an odd power, then negative to an even power. All right, so here's this one. We're going to expand and simplify x minus 3 to the fourth power. First thing I want to do, let's take a look at our coefficients for the fourth power. And this is 1, 4, 6, 4, 1 from our Pascal's triangle. So let's go back and we'll write in our coefficients. I've got 1, 4, 6, 4, 1. All right? First of all, I've got x to the fourth power here. Then I've got x to the third and a negative 3 to the 1 power. Then I've got x squared, drop off an x, and now I have negative 3 squared. Drop off an x, so I have just 1x, and I have negative 3 to the third power. And lastly, my x drops off, and I have negative 3 to the fourth power. All I have to do is multiply all of this stuff out. So this starts out easy, x to the fourth. I've got a 4 times a negative 3, which is minus 12x to the third. Negative 3 squared is 9 times 6 is 54. So plus 54x squared. Negative 3 raised to the third power is negative 27. Multiply that by the coefficient of 4 and we get minus 108x. And then negative 3 raised to the fourth power is 81. So plus 81. All right, the next example and our last example, it says the first three terms of the expansion of a plus b to the 20th are and we have 3 terms. Write the last 3 terms. Let's go back to that Pascal's triangle, because I want you to notice something. I mean, it gets kind of cumbersome, and the coefficients get quite large. But notice something. They're always the same from both ends in. 1, 7, 21, 35. Okay? 1, 6, 15, then the middle is 20. So the first 3 and the last 3 are going to have the same coefficients, just in reverse order. All right? So let's go ahead and write those last 3 terms. So my last 3 terms are going to be 190, 20, and 1. All right? And notice this. Here's what's going to happen. And our very last term, this is going to be b to the 20th. Because that's what we're left with for our last term. So let's work this way from right to left. Here we're going to have 1a and b to the 19th. We took away a b, added an a. Let's do the same thing in reverse. So here we have a squared b to the 18th. And those are our last 3 terms.